All right, let's talk about securing AI. The best way to wrap your head around it is to think of it like building a super high security vault. And there's one golden rule, the most important rule of all. You build and test that vault before the gold rush, not while it's happening.
So let me ask you a question, and it's a simple one. When do you really truly test a bank vault's security? After it's already stuffed with cash? While a heist is in progress? No, of course not. You do it before a single dollar bill goes inside. Now, I know that sounds ridiculously obvious, right? But believe me, this is the single most important idea in AI security. You have to secure the model right from the requirements phase, way before it's ever deployed or touches any real sensitive data. And you've got to understand the stakes are sky high. Because the second an AI model goes public, it's basically got a giant target on its back. Attackers are going to probe it relentlessly, 24/7, looking for any little weakness, any tiny crack in the armor. You just don't get a do-over on building the foundation right. Okay, so how do we actually build this vault the right way? Well, it all starts with a solid blueprint. And that blueprint is built on two fundamental pillars of protection. This is how you create an AI that is what we call secure by design.
That's it, just two. Getting these two things right from the very beginning, that's the whole ballgame. It's the key to making an AI system that's not just powerful, but also resilient and trustworthy. And here they are. Pillar number one is what we call model evaluation. The easiest way to think about this is the stress test. It's like hiring a team of the world's best safecrackers to try and break into your vault before you open for business. Then, pillar number two is model guardrails. Now, these are the vault's permanent automated security systems. We're talking the laser grids, the pressure plates, the silent alarms, the stuff that runs 24/7 to enforce the rules no matter what. So let's really dig into that first pillar, model evaluation. This is the active, kind of offensive part of the process. This is where we put on our black hats and we intentionally try to break our own creation. Why? To find the flaws before the bad guys do. So what does model evaluation actually mean in plain English? It's this whole exhaustive process of stress testing, auditing, and basically trying to hack the model before a single real user ever gets to touch it. This isn't just about checking if the model gives the right answers. It's about seeing if it's tough, if it's safe, and if it can be easily tricked.
So when we're doing this testing, what are we actually looking for? Well, first, there's adversarial robustness. Can an attacker trick it with some clever prompts, jailbreak it? Second, data risk. Can we accidentally shake some secret info out of its training data? Third, hallucination and reliability. Does it just make stuff up and state it as fact? Fourth is alignment validation. Does it actually stick to the safety rules we gave it? And finally, supply chain integrity. How do we know this is the real, untampered model we think it is?
And let me be absolutely crystal clear about that data risk part. If your model starts leaking sensitive customer information or internal company secrets, that's not just some small technical glitch. That is a massive regulatory nightmare waiting to happen, and it's an irreversible compromise of the model. You can't put that genie back in the bottle. And you've got to understand, when these models lie or hallucinate, it's not just about being wrong. It can be actively dangerous. I mean, imagine an AI inventing hazardous steps for fixing a critical piece of machinery, or just completely fabricating internal company policies out of thin air. This isn't just an error. It's a huge risk to the entire enterprise. All right, so that brings us to our second pillar. How do we build on all that stress testing work? Well, once we've tried to break the vault, it's time to install those permanent, automated security systems that never sleep. It's time to install the guardrails. So, model guardrails are pretty much a security buffer. They sit right between the AI model and the outside world. Their entire job is to make sure the model behaves safely and predictably, even when someone is deliberately feeding it hostile input. Think of them as the model's always-on, 24/7 security detail. Let's break down the layers of that system. You've got your system-level guardrails. That's like the Vault's core programming. It's master command. Then you have prompt templates. These are like mandatory, highly structured access request forms. No one just gets to yell commands, they have to fill out the form. Input filtering, that's the security scanner at the Vault's entrance. And output filtering is a scanner at the exit. Finally, tool and API controls are the super strict rules for what the Vault's internal robot arms are even allowed to touch or do. Now, here's the really crucial thing to get about prompt templates. They stop users from just talking directly to the raw, uncontrolled model.
Instead, every single request gets wrapped in this protective layer of rules, context, and safety constraints before the model even sees it. It's the difference between letting someone just wander around a sensitive facility shouting orders versus making them fill out a detailed, authorized form for every single thing they want to do. So, let's bring this all home. When you combine that hardcore, rigorous evaluation with smart, automated guardrails, you don't just get a secure system, you get something much better. You create an AI that is secure by design, right from its very core. Your model is now a fortress. So let's just quickly recap that first pillar, model evaluation. This is where you proactively test your model's defenses against manipulation. You work to prevent any data leakage. You validate that it actually follows your safety policies. You check for those dangerous hallucinations. And you verify that the supply chain is clean, that the model is what you think it is. And for the other half of that equation, the guardrails. This is where you use system prompts to set permanent, unchangeable rules. You structure every single interaction with prompt templates. You sanitize all the inputs to stop attacks before they start, and you filter the outputs to prevent leaks on the way out. And you tightly control any access the model has to other tools or APIs. At the end of the day, security isn't just a feature you bolt on later. It's a fundamental requirement from day one. And that leaves us with one final, pretty important question. Is the AI you're building a fortress, secured from the ground up, or is it just a glass box, waiting for the first stone to be thrown? That choice is made long before the first user ever logs on.